La doctora Annie Fogel, profesora en Patología, Microbiología y Neurología en la Universidad de Vanderbilt en Estados Unidos. Es editora asociada en la revista americana de Nefrología, INTERNACIONAL, y miembro constante de distintos comités de patología de la Sociedad Internacional de Nefrología. Nos va a hablar de glomerulosis focal y segmentaria, una vía común final al daño podocitario y a las alteraciones hemodinámicas del glomérulo.
So the microphone is working, the slides are up. Gracias, Felipe, very nice. I am delighted to be back in Portugal for my second visit, and I thank you for the opportunity to tell you about my perspective on FSGS. So first I want to tell you about a patient, a 44-year-old white man who was said to have end-stage renal disease because of focal sclerosis. He received a transplant 18 months ago, and now he has increased serum creatinine and proteinuria. But they do not tell me how much, some proteinuria. So on Friday afternoon, we received from the outside hospital the transplant biopsy slides with a diagnosis of recurrent FSGS, and 52 slides were sent to me for review. And they asked me, Agnes, what does he have? So I want you to think about, what is your clinical differential diagnosis? What additional information do you want? How can we help the patient and the clinical team taking care of him? So we will do it by hands. How many think he has recurrent FSGS? How many of you are tired and not thinking? Well, you need to be honest. You either raise your hand on an answer or raise your hand, I'm too tired, I don't want to. Okay? So how many think he has transplant glomerulopathy? Nobody is grading you. You can raise your hand. See, we have brave people around here. How many think he has antibody-mediated rejection with secondary membranous nephropathy? It would be PLA2R negative. Somebody, maybe. How many think he has chronic allograft nephropathy? Maybe. And how many says, I have no idea? Okay, a few more hands. Okay, so we're going to have some fun now in the next 30 minutes, and we will come back to this patient, but right now, we don't really have a good idea, and I have 52 slides to look at. So, FSGS is a very confusing terminology. It is both a lesion, just meaning scarring in some glomeruli, focal but not all, and a disease. So we use this term for the idiopathic FSGS caused by a circulating factor or any secondary scarring. The idiopathic form almost always has nephrotic range proteinuria and often full-blown nephrotic syndrome. And some glomeruli, focal, are scarred in a segmental pattern, and we don't have any immune complexes. It is the most common cause of nephrotic syndrome in adults in the US, and we have extensive foot process effacement in primary FSGS, even in non-sclerosed glomeruli, because there is an initial severe podocyte injury. In secondary segmental glomerulosclerosis, we often, but not always, have less complete foot process effacement. But we can have a lot, particularly if the glomerulus we are looking at has a segmental lesion. So I use a little trick in my reports. If I have segmental sclerosis, but I have clues I will tell you about in a minute, that I can say, oh, this is not primary FSGS. I don't put the words focal segmental glomerulosclerosis in a row, because all of you, all nephrologists in the US, if I say FSGS, they think circulating factor, recurrence in transplant, primary disease. So my trick is, listen to this carefully. I say glomerulosclerosis in focal and segmental pattern. Now you have to think and read the rest of my report. So secondary sclerosing lesions without immune deposits are very many. For instance, viruses like HIV, parvovirus, SV40, CMV, Many drugs, interferon therapy, pamidronate, or maybe other bisphosphonates, anabolic steroids, calcineurin inhibitors. Genetic causes, such as Alport, linked to collagen 4 mutations, may have a lot of proteinuria and secondary scarring. Other genetic diseases like Fabry disease may have segmental scarring, no immune complexes, and we need the EM to determine exactly, this is not primary FSGS, this is secondary, we can do genetic testing. We also have adaptive secondary segmental sclerosis. With any disease where there is a big loss of nephrons, we can get secondary scarring in the remaining nephrons that have to work so hard. In obesity, many factors are involved, adipokines, hemodynamics, maybe some early dysmetabolic area. Unfortunately, in the US, we are getting much more of this too. And we have the risk, not just from genetics, as Dr. Garadi told us, but from low birth weight. So how many of you know your birth weight? You do? Only 3 people know your birth, or more know your birth weight? Okay. So at the coffee break, if you are fortunate enough that your mother is still living, don't call your father. He will not remember. Your mother will remember. Call her. And if you were lucky, you were more than 2.5 kilos at term birth. Maybe we should ask our patients with low birth weight, they may have fewer nephrons and have epigenetic marks and risk for adaptive secondary sclerosis. So here are some examples of secondary sclerosis. Sometimes we have hypertension-associated disease. We call the lesion arterionephrosclerosis. You can see here segmental scarring, but globally sclerotic glomeruli, very severe vascular disease, subtotal foot process effacement, endothelial injury by EM. I can say, this is not primary. Most of the time, I can tell. Chronic post-immune glomerulonephritis. We will hear about vasculitis later in the meeting. The scar of this vasculitic crescentic lesion will have a broad-based adhesion, maybe a fibrous crescent. I can say this is not primary FSGS. Chronic pyelonephritis or reflux. I can see sharply delineated areas of scarring like a jigsaw puzzle, limited foot process effacement. These are some of the patterns, many clues from pathology. So when I look at a biopsy, I have fun, like Sherlock Holmes solving a mystery. If I have collapsing glomerulopathy, maybe the patient is HIV infected, or maybe it's idiopathic or some other cause we'll talk about more. I showed you the severe vascular sclerosis, reflux nephropathy. If I have very, very big glomeruli, maybe the patient has sickle cell nephropathy, or oligomeganephronia, born with too few nephrons that are all very big, more risk for scarring. Maybe they only have one kidney, either unilateral renal agenesis, an inborn error, or they have a nephrectomy at a very young age, or maybe they have obesity. I can put all the clues together. So let's go back to what we think of as primary FSGS. The incidence has increased very much in the US, now maybe leveled off, particularly in African Americans, and we don't know why. It's not because of a change in biopsy before. In the biopsy sample, I look for segmental scarring. Here on the PAS, obliteration of capillary loops. Here on the syllable stain, I can see a glassy incidation of plasma protein. Often we have hyalinosis, not diagnostic, not specific. I will by EM see extensive foot process effacement in primary FSGS, but also I can in some secondary forms. And if you are a pathologist looking at EM, remember the hyaline, that incidation of plasma proteins, has a dense appearance by EM. Don't go crazy and say, oh, I missed immune complexes. It is hyaline. You can correlate with the scout sections for EM and the immunogenesis. So let's think how we used to classify renal disease. We will have a coffee break soon. So it's appropriate that we think a little bit about what we should do or not do in the coffee break. You can see here the medieval piss prophets. This is very polite Old English. There it is, P-I-S-S-E, polite Old English. they were very wealthy, and they looked at the urine that the servants wearing short coats brought from the Prussian princes in medieval Europe. And they were very well trained. They had a training period like residents and fellows, and they had uroscopy charts. They could look at this and they could say, if you have dark urine, it's very bad. What do you think that was? Probably infection-related, acute GM. They knew if your urine was foamy, it was very bad. Nephrotic syndrome. They knew if flies came to your urine, it was bad. They even knew about diabetic nephropathy then. And they had textbooks, so I will teach you something from the textbook of medieval time. Is it not proper that the patient or a servant should taste the urine? The answer, it is below the dignity of the physician to do it. So in the coffee break, do not taste the urine, yours or anybody else's. But it may be done by the patient himself or his servant, who may give an account of it to the physician, by which he may obtain some light into the distemper, the sickness. If he cannot do that, he had better inquire nothing about it. This means, if I cannot shed some light into the disease, I should not be doing study of the disease or kidney biopsy. So I want to show you how we try to have some more light onto FSGS and minimal change disease. Classically, we need a big enough biopsy to detect the presence of segmental sclerosis. It's very early, in the early stages, very few glomeruli. So guess how many glomeruli I want to have a good chance of detecting a 10% prevalent lesion? 25. How many of you get 25 glomeruli for me or your pathology colleagues by LM? Oh, you are very honest. None of you get 25. You get maybe 10, maybe 8, maybe 15 glomeruli. So maybe I will miss the early lesion. If I have a young patient, and my apologies, none of you are biologically young. This is after teenage years. We all begin to have a little bit more age-related scarring. If you are young biologically, a child, adolescent, teenager, you should not have significant tubulointerstitial fibrosis. So if I see that in a young patient, I will cut more sections looking for the unsampled FSGS. We did studies in the interest of time, I won't go through, if we found marked glomerulomegaly. These are not obese patients, not unilateral greenlagenesis. This was associated with disease that progressed to FSGS. The degree of foot process effacement is exactly the same in minimal change and primary FSGS. It doesn't help at all. So some people say, is this minimal change disease and FSGS spectra of the same disease or two diseases? Well, clinically they both show nephrotic syndrome, but the main populations affected differ. Minimal change disease mainly occurs in children between 1 and 7. But it also can occur in other populations, adolescents, middle-aged, and senior people also, but most common, most patients are young. There's foot process effacement that's extensive in both, but even at the earliest phase, I'll show you later, there is different immunostaining and different proteomic profiles of the glomeruli, indicating at the very earliest stage they overlap. So even though some overlap features exist, divergence at an early time, in my opinion, not proven, supports separation. So what are the mechanisms of this injury? We know that FSGS recurs in the transplant. The clinical predictors are young age at onset and a rapid course to end stage. The circulating factors have been tried to be identified. SUPAR, soluble urokinase plasminogen activator receptor, was studied, but now we know it's a non-specific acute phase reactant and not the specific causal factor for recurrent FSGS. Maybe it can predict CKD as an acute phase reactant. Cardiotrophin-like cytokine 1 was found by Ginny Sabin, but other people have not been able to reproduce it. So we do not know the magic circulating factor. Maybe there is more than one. We do know that when the FSGS recurs, it usually replicates the morphologic pattern of the original disease, not always. So when it recurs and you do a biopsy, immediately when the nephrotic syndrome occurs, look what we see. Here I'm showing some of the 20 glomeruli. On this silver stain, they are normal. By light microscopy, there are no deposits by immunofluorescence. At this stage, all we have is complete foot process effacement. Here is the glomerular basement membrane, the podocyte and urinary space, the mesangium, complete extensive foot process effacement. I do not sign this out as minimal change disease. Minimal change disease is a clinical pathologic diagnosis that is steroid responsive and does well. I know this is recurrence of FSGS. I sign this out as extensive foot process effacement, and in the comments say this is consistent with the early pre-sclerotic phase of recurrent FSGS. So what can we learn about new things to look at etiology of an FSGS lesion? I will not go into detail of genetics. I will show you a little bit about phenotypes and proteomic data. We don't have time to talk about all of this. Here is a partial list of genes that have been associated with and are causal, proven to be causal in development of FSGS. Some of them have disease manifestation in adults, indicating there must be multiple hits that are necessary for the disease to be manifest. Some of them happen very early on. The collagen 4A mutations have been associated with segmental sclerosis, but this, when you look at the EM carefully, which I always look at the EM carefully, you can see these are outward patients. They just have a more dominant phenotype of proteinuria and secondary segmental scarring. They don't have all of the classic eye and ear changes. This slide given to me by Dr. Hildebrandt was very, very helpful to me because it shows that we can begin to put things together in terms of the molecular pathogenesis and understand at a precision medicine level these young people with steroid-resistant nephrotic syndrome, FSGS, who have genetic causes. Most important are the CoQ10 biosynthesis defects because these can be treated specifically by giving supplementation with CoQ10. For the other abnormalities, actin binding, slit membrane, lysosome, actin regulation, nucleophorins, endocytosis, we do not have specific pathway targeted treatments. Maybe it will come, but this is an example of the direction which we are moving. If you have a child or family history of FSGS, you absolutely should do genetic screening. But the yield in adults without a family history of finding a causal gene mutation is very low, almost zero. The younger the patient, the higher likelihood there is a gene that is responsible, at least in part, for FSGS. And of course, with a family history, we think about this. In addition to these monogenic causes, we recognize that African Americans have been studied, particularly in the US and in Africa, have excess renal disease, and genetic risks have been looked at for these populations. The first GWAS linkage was found with non-muscle heavy chain 9, but it turned out this gene is right next to apolipoprotein 1. And apolipoprotein 1 has risk alleles that are highly associated with increased risk for some kidney diseases, developing them, and increased risk for progression, even in diabetic nephropathy. Why is this gene so highly expressed in those of African ancestry, Black African ancestry? We think it is because it confers a survival benefit for sleeping sickness caused by Trypanosoma brucei, similar to the population pressures for sickle cell disease being highly prevalent in this population because it protects against malaria. We don't know the mechanisms for kidney disease risk. It requires additional hits, but we have evidence from animal models with very complicated mice making humanized mice. Mice don't normally express ApoLA1, showing that there is a podocyte injury when you express the risk allele variant on podocytes, but not the normal allele. We still don't have absolute proof, and we certainly don't have treatments. So, unfortunately, the genetically determined FSGS we don't have great morphologic clues for most of them. The exception being congenital nephrotic syndrome of Finnish type and the mitochondrial diseases. I can tell some abnormality there. There are no known prognostic indicators for progression. We understand that a few of these patients develop nephrotic syndrome after transplant. There appears to be an immune reaction to the normal kidney, not immune complex, but immune reaction that causes injury. It doesn't replicate the genetic abnormality, but causes injury to the podocytes. So is all non-genetic FSGS that appears primary the same? Can morphology tell us anything of importance about FSGS? Can I tell you something about the distemper? Important for prognosis, etiology, or response to therapy? So I'm sure all of the women in the audience will be very happy that there were women PIS prophets also. They were very clever also. And I think of myself as a more modern day woman PIS prophet. And here are 5 patients that I diagnosed with FSGS. Now, very few of you are pathologists, but you can tell they look very different. Let me show you how a small working group of pathologists, myself, Dr. Babette Tagadi, Dr. Jan-Anthony Brun, and Dr. Charles Jeanette, said these different appearances, we're calling them all FSGS. Let us make a proposal to divide them according to the lesional morphology and see if it matters at all. We don't have evidence when we said this. We said this is a hypothesis, let's test it, work together. So we divided, based on our experience and planning to test it, FSGS into the not otherwise specified type, the collapsing type, the tip lesion, the cellular lesion, and we included the hilar lesion. I will explain all of these to you because we wanted to test whether our impression that this was a secondary adaptive type lesion was true. So we recognize that mixed lesions exist in many biopsies. Not all the segmentally sclerotic glomeruli are the same in pattern. So we had to make rules for hierarchical class assignment. Like if you play poker, you have rules of which hand of cards is the best. And we had to make mutually exclusive categories. So this is not Game of Thrones, this is Game of FSGS. First, we look for a collapsing lesion. We decided this is the #1 thing. If I find even one collapsing lesion, I'll show you how we define collapsing in a minute. We will call it collapsing variant, regardless of what the other glomeruli show. If I don't have collapsing lesions, let me hunt for a tip lesion. If we find a tip lesion, we have to look also, do I have lesions at the hilum, at the vascular pole? If I have both, then it's NOS, a mixed bag. But if I only have tip lesions without hilar lesions, we'll call it tip variant. If I don't have collapsing or tip lesions, let's look for cellular lesions. And if I don't have the cellular lesion, let's look for the hilar lesions. If this is the dominant lesion in the segmental sclerosis lesions, we'll call it hilar pattern. And if it is not, if it is just a few glomeruli, then we will call it NOS. And if I don't have special types, I will call it NOS. So let's look at what these types look like. The NOS is the most common form of FSGS. It excludes other special variants. And over time, when you get close to the end stage, all of the glomeruli may show NOS lesions. Here's a schema showing obliteration of the tuft segmentally by matrix. And this picture I've already shown you, segmental scarring involving part of the glomerulus. The cellular variant is the least common variant. It includes endocapillary hypercellularity, no immune complexes, extensive foot process effacement, and we use this term when we exclude tips and collapsing variant. And you can see here on the silver stain, we have endocapillary foam cells, some macrophages in this part, and you have to exclude immune complexes by IF and EM. Then we come to the tip lesion, very interesting. This is defined by having sclerosis or adhesion at the proximal tubular pole. And it may have endocapillary proliferation and also some increased cellularity outside the tuft. So you can see here cellularity outside the tuft and endocapillary hypercellularity. And this is what it looks like in real life. Here you have the proximal tubular pole on the silver stain. You can see the proximal tubular epithelial adhesion with foam cells with a tip lesion. So this is remarkable how these patients do. In a study of 47 patients with tip lesion from the Columbia group, they found remission in response to immunosuppression in almost 2/3 of patients, and partial remission in 14%, and only one patient progressed. This lesion was initially described by Alec Howie in Britain. In his patients, if they had only tip lesion, at 10 years, less than 10% developed end-stage renal disease. If you had tip mixed with others, then we would call it a FSGS-NOS. At 10 years, 45% had end-stage kidney disease. So let's look at the other pattern, perihilar hyalinosis. This is defined by most of the segmental scarring involving the hyaline after we excluded the other special types. And here you can see on the silver stain the vascular pole with the arteriole, the interlobular artery, and here we have scarring at the vascular pole with some hyaline. And then we have the very worst kind, the collapsing lesion. We put forth the definition that you need to have collapse of the tuft. If I'm going to make a funny face for you, maybe you'll remember this when we have cocktail hours later. Like this. That's not enough. You have to also have proliferation of the overlying visceral epithelial cells. So you cannot just have ischemic shrinkage of the tuft. You have to have the cell reaction of the overlying cells. And sometimes we have associated cystic tubular lesions. So here is a segmental collapsing lesion. The tuft is all shrunken, but we also have hypercellularity of the overlying epithelial cells. And it can be segmental, or as in this case, a global lesion. This lesion has many causes. Has many causes. You can see it with viruses like parvovirus, CMV, or HIV, pamidronate, interferon treatment, anabolic steroids, severe ischemia. We had one patient who had this because he liked to take cocaine all of the time. He quit cocaine, he was much better, his edema went away, and he came back to the nephrologist. Dr. Zent told me, he said, "Man, Dr. Zent, I like that cocaine too much, forget about stopping the cocaine." And immediately his collapsing glomerulopathy came back with edema. Calcineurin inhibitors can do this also. They cause ischemia and can cause a collapsing lesion to transplant. Sometimes we see it even superimposed on severe immune complex disease in lupus patients, and this has a very bad outcome. Look compared to the usual control FSGS. Collapsing FSGS, whether it's idiopathic or HIV related, has a very bad outlook. And when we look at the literature in more detail, those cells that are over the tuft, you would think they are podocytes, but they do not mark like podocytes at all. Podocytes normally do not express a proliferation marker Ki67. They express Wilms tumor, antigen, GLEP1, podocalyxin, synaptopodin. These proliferating cells that are on the tuft, visceral epithelial cells, whether it's high band or collapsing glomerulopathy, are proliferating, and they've lost all podocyte markers. So what could be going on with them? Well, we now know that cells that are at the vascular pole, the parietal cells there, can be very busy. They can walk from Bowman's capsule and they can walk onto the tuft. They can move on, they have little feet, they become transitional, and we know in development and with some severe injury, parietal epithelial cells can migrate onto the tuft. So in some settings, this is part of an effort to replace podocytes. They can transdifferentiate. In other settings, these parietal epithelial cells help to drive scarring. So we wanted to look at activation of parietal epithelial cells in FSGS. CD44 is a cell surface glycoprotein involved in cell-cell interaction, adhesion, and migration, and it stains activated parietal epithelial cells, PECs, and some lymphocytes. And we showed first that proliferating glomerular epithelial cells in collapsing glomerulopathy are actually activated PECs. they're not podocytes. So we wonder, in that early phase of recurrence of FSGS in the transplant, when it looks like native kidney minimal change disease morphologically, do we have some parietal epithelial cell activation that can distinguish this from minimal change disease? And the answer is yes. So we did a study where we looked at native kidney minimal change disease. You can see here, staining for CD44, there is no staining. And then we looked at recurrent FSGS before there is scarring. And the parietal epithelial cells are positive, lining Bowman's capsule, and there are positive cells onto the tuft that have migrated over. So we have found that PEC activity is significantly increased in evolving FSGS, even native kidney early FSGS versus minimal change disease. And this may help in those small biopsies. It may help me to distinguish minimal change from FSGS. So with my colleagues, Dr. Alpers and Dr. Degatti, I got a grant from the NIH to study archival biopsies. And we wanted to see whether podocyte or PEC injury differs amongst the morphologic variants in FSGS. We could see that the collapsing glomerulopathy had these abnormal activated PECs on the tuft. And are the intact glomeruli, the ones that don't have scarring by light microscopy, or the areas in the segmentally sclerosed glomerulus, how abnormal are they? Are they affected by their adjacent environment? So we looked at 240 cases. We included normal, native kidney, minimal change, and the variants of FSGS. And I won't show you all of the detail, but I want you to see just here the summary part of how different these are. We analyzed the staining for various markers. Claudin-1, a marker of quiescent parietal epithelial cells. CD4, a marker of activated parietal epithelial cells. WT1, a marker of mature podocytes. We looked in the visceral epithelial cell area, the cells that are on the tuft. And as I showed you, the collapsing lesion has marked increase in activated PEC staining there, and very little WT1. Those cells are not podocytes by immunostaining. If we look in the parietal epithelial cell area, we also have a marked decrease in WT1 staining. But look at the tip lesion, the one that does so very well. We have quiescent PECs, we have marked maintenance of WT1, and the PEC areas have quiescent cell staining for Claudin-1 and WT1. And the perihilar lesion that we think is adaptive and secondary had no activation of PECs, no activation in either location. So from this, we think that podocytes and PECs show varying phenotypes amongst the different variants, suggesting that there are different intermediate mechanisms underlying the morphologies. I didn't show you the data of the non-affected glomeruli, or the areas without segmental sclerosis, but they have very mild changes, but they are not the same as normal or minimal change disease, suggesting these changes could proceed and cause structural FSGS. And very interestingly, the glomeruli that have no segmental sclerosis in any of the variants have heterogeneity in the podocyte and the PEC phenotypes, suggesting that glomeruli are affected by the adjacent microenvironment. So whether this is cell-to-cell contact or soluble factors, we don't know. But from the morphology, we're beginning to understand the heterogeneity. But let's go back to the clinical importance of these variants. Here, from the UNC series of adult FSGS cases, you can see that they looked at the different lesions, and you can see that collapsing are almost all black, but not all. You can see that the tip are almost all white, but not all. You can see that tip has the very lowest serum creatinine and a very high remission. And look here, nephrotic syndrome was much more rare in perihilar variant, and they didn't respond very well to treatment, and collapsing didn't either. So this supports our idea that the hilar lesion is probably a secondary adaptive lesion, not much use for immunosuppression there, and the collapsing lesion does not respond and the tip does. So looking at the renal survival from the UNC, you can see here that we had the very worst in collapsing, the very best in tip and intermediate for the perihilar and NRS. And here from Columbia, we can see the same type of picture. Collapse has the highest incidence of end-stage renal disease. TIP is much better. And we can see the reverse, the remission, is the very highest in TIP and much lower in collapsing. So some nephrologists have said, morphology doesn't matter. All that matters is if the patient responds. And of course, all that matters is if the patient responds. But we wanted to see if we control for therapies, does the morphology give us any hint of the likelihood of response? So we were able to study the FSGS clinical trial. These were steroid-resistant patients, young patients up to age 40, and there was a comparison in these patients who had failed steroids of MMF dexamethasone versus calcineurin inhibitor on top of usual ARB and ACE. And we looked at the outcomes. And we had compared morphologic type and influence on outcome. So you can imagine, since all of these patients failed steroids, we would not have so many TIP cases, right? I've shown you already, TIP cases behave more like minimal change disease. But even where we had had a bias against TIP patients, we had some TIP patients, and look what happened. The TIP patients had the very best outcome, the collapsing had the very worst, the NOS were in between. So here we have normalized for the treatment effect, we have weeded out those that responded to steroids, and the morphology still tells us something of utility. So let's go back to our patient. I asked, what are your clinical differential diagnosis and what additional information do you want? And those of you who raised your hand said, oh, I have no idea. So I looked at the information I got, FSGS, primary disease, recurrent FSGS in the biopsy, and I called the nephrologist and I said, I need more history, and I need to have the native kidney biopsy slides sent for my review. This history of FSGS, I told you how tricky those words are, is no good. So I got it the following week, on Tuesday the following week, and it turned out he had congenital obstruction with a solitary kidney. And then I got the native kidney slides, and look here. What do you think? Does this remind you of any pattern we looked at early in our time? Look here, very sharply delineated scarring. Yes, he has segmental sclerosis. I think this looks like reflux nephropathy, chronic pyelo. Here I have a hilar pattern of scarring. I have some ischemic corrugation, but I don't have any hyperplasia of podocytes. And the EM had very little foot process effacement. So now, my diagnosis is secondary segmental sclerosis consistent with reflux nephropathy. This is his primary disease. So now, what is your clinical diagnosis of the transplant now? How many think it's recurrent FSGS? If any of you say yes, you have to have a teaching session with me afterwards. No, it's not, because he didn't have primary FSGS. What about transplant glomerulopathy? Yeah, he could have that, that's possible. What about antibody-mediated rejection with a membranous nephropathy? He's 18 months out, received late antibody, nobody thinks he has this? Chronic allograft nephropathy? Yes, maybe, with secondary FSGS? Yeah. But we need to look at the biopsy, don't we? So, this is one of the transplant biopsies. What do you see? Is it normal or abnormal? Abnormal, great. So it's a silver stain. How can you describe the lesion? Is it usual? It's abnormal. Is it usual type segmental sclerosis or a special type? Special type. Which special type? Collapsing. You are so brilliant. So look here. We have, remember my face? We have the tuft. It's a little bit dark up here, tuft, and we have hyperplasia. I have another glomerulus. You can see the hyperplasia of the visceral epithelial cells. So, he doesn't have any immune complexes by IF. I have ruled out membranous nephropathy due to AVMR. There was no microcirculation inflammation. So what do you think the etiology is of the collapsing glomerulopathy? HIV? Pamidronate? Calcineurin inhibitor toxicity, maybe? Maybe he took anabolic steroids or something. We don't know. But, yeah, something. Exactly. So we have to look at the EM. So let's look at the EM together. Here's the close-up of the glomerular basement membrane. So what do you think about these foot processes? Normal or effaced? Effaced. What about these, normal or effaced? What about these? Intact, right? They look like little ballerinas on point. So he had subtotal foot process effacement, and I didn't show you pictures, but he also had some nodular, arterial, or hyaline that extended into the media. So now what do we think? Well, it's not recurrent FSGS. The EM did not show any increased lamina rara interna transplant glomerulopathy change. We have ruled out membranous. We didn't find any reticular aggregates to suggest it is HIV nephropathy, and usually that has very complete foot process effacement. And I have other morphologic findings that fit with calcineurin inhibitor toxicity. So all of you, I'm sure, chose number 5. So, native kidney diagnosis, we needed to know this for a complete interpretation, showed secondary segmental sclerosis consistent with reflux. The transplant biopsy showed collapsing type glomerular lesions, suggestive, consistent with calcineurin inhibitor toxicity. So what do you think happened with him? So this is a very good story. Instead of getting plasmapheresis and very strong immunosuppression, they decreased the calcineurin inhibitor dose, right? Gave him ACE inhibitor ARB, and he had on follow-up minimal proteinuria with a stable serum creatinine. A follow-up biopsy 4 months later showed mild transplant glomerulopathy, intact foot processes, and striped interstitial fibrosis, consistent with calcineurin inhibitor toxicity. And we didn't have any evidence at any time for this. I don't know if that's endothelial injury or ABMR. So I've shown you in this time together, we have many different initial injuries, we have some genetic modulation, we have many mechanisms, we are having fun in pathology to try to understand them better, and we have diverse histologic manifestations and also clinical correlates of sclerosis. So when I look at biopsies, I have so much fun. I am like Dr. Holmes and Sherlock Holmes and Dr. Watson, trying to put together the mysteries with my friends, the nephrologists. So do you ask, do appearances matter? I look at the biopsy. Yes, it does. And if we look at all of the appearances, we can say, is this a zebra neph or something else? So my last slide is to thank all of my collaborators and people in my lab, and to thank you for interacting with me for this talk. Thank you very much.
¿Alguna pregunta en la audiencia? Excuse me, about the morphological classification.
Yes.
Could these lesions switch between them over time?
Yeah, this is a very important point. I just had a very brief slide on this. The natural evolution, if the patient progresses, is that you go on to NOS scarring lesions as the kidney reaches end stage. So these lesions are not static, they can change, but at the time of biopsy, the morphologic appearance has some association with the likelihood of response. But they're not fixed, unique diseases. They are stages, pattern of injury that may be in some flux. And particularly the collapsing lesion has many etiologies. We can think about those etiologies specifically, ischemia, pomidronate, calcineurin inhibitor toxicity, HIV, other viruses. These are not particularly associated to cause the other patterns of injury. And it can be idiopathic, the collapsing lesion.
Sí, me pareció muy bien.
Yes?
Me pareció muy bueno cuando habló de la recurrencia de la esclerosis focal y segmentaria, de la FSGS, en la situación de post-trasplante, en el sentido de que el solo hecho de encontrar el borramiento de los pies de los podocitos es hallazgo suficiente para declarar la recidiva de la FSGS primaria, sin ver ningún tipo de escara en la biopsia.
This is a very excellent question. So I need to know the clinical setting, right? So in the clinical setting where we know that the primary disease is FSGS, primary FSGS, and the patient has marked proteinuria, extensive foot process effacement is diagnostic of the early phase of recurrence of the process that leads to FSGS. So if you remember back to medical school days, anybody remember? You learned about myocardial infarct, and you learned about coagulative necrosis, you learned about acute inflammation, chronic inflammation, remodeling, granulation tissue, wound healing, fibrosis. Do you remember how long it takes to get a scar? About 7 to 10 days. This is why 5 to 7 days is when your patients will rupture from a transmural myocardial infarct. So it takes a little bit of time, maybe a couple of weeks to develop the scar, but the initial injury is to the podocyte. But I need to know the setting, because complete foot process effacement or extensive foot process effacement is not unique to the injury caused by the circulating factor or factors in FSGS. We see it in membranous, we see it in advanced diabetic nephropathy, we see it in membranous lupus, we see it in any setting where there is a lot of proteinuria. But when I have no immune complexes, and I know that's the primary disease, and the patient has proteinuria, it is sufficient.
La buena noticia es que para ese diagnóstico no hacen falta tantos glomérulos. Es suficiente con tener 1 o 2. No necesita los 25.
Yes, but please give me 25 anyway. We have follow-up biopsies in these patients, and at the World Congress of Nephrology, I am giving a talk in the pre-meeting course on recurrent glomerular diseases, and I reviewed all of our Vanderbilts, and we find that primary FSGS usually recurs in the first 3 months. It's very, very, very rare after 1 year. And the secondary segmental sclerosis has subtotal foot process effacement and has other EM findings, and is a later occurrence, like transplant glomerulopathy, hypertensive associated disease. So yes, if I got a biopsy from you, Javier, where I only had 1 glomerulus in the EM sample, and I knew the patient has primary FSGS and has marked proteinuria, and I have complete foot process effacement and no immune complexes, I can tell you this patient has recurrence. In that clinical pathologic setting, we need to integrate all of the information to make a precision medicine diagnosis.
Thank you, Dr. Fogo, for your talk. It was great. I have a question for you about how important is for you to make the electron microscopy in each renal biopsy? Because here we have some really hard problems with electron microscopy, and I want to hear your opinion.
There are some diagnoses that you can make very confidently by light microscopy immunofluorescence. We have just heard a wonderful lecture by Dr. Garabi. I don't need EM to say that I have IgA dominant immune complexes, but maybe in some cases the EM can help me to find in the late stages some scattered hump, and I can suggest to you the C3 is very strong, maybe it's a staphylococcal associated IgA. Some very beautiful studies by Mark Haas show that in native kidney biopsies, you miss about 18% of diagnoses if you don't do EM. And the problem is we don't know the ones where we will miss something. Things like thin basement membrane and Alport syndrome, you cannot diagnose from light microscopy or standard immunofluorescence. Things like fibrillary glomerulonephritis, we can suspect it from smudgy immunofluorescence staining. Now we have an immunohistochemical stain, DNA JB9, to diagnose. But sometimes the substructure or the exact nature of the deposits is illuminated by EM. For transplants, we do EM when the immunofluorescence is positive or when there's marked proteinuria. And we do EM on all native kidney biopsies. And I think to evaluate a segmental sclerosis lesion, without EM, it's very difficult to be able to give the nuanced assessment of the differential, looking at the extent of foot process effacement and other GBM findings, or early diabetic injury for that matter. I think it's important, but I recognize that you may not have the resource all the time to do it, but it should be done ideally.
Thank you.
¿Alguna más? Excuse me, could you explain something about the role of the parietal epithelial cells in the repair and not in the progression,
Yes.
the progression
Yeah.
of the early stages in the podocytopathy of the FSGS?
Yes, this is a wonderful question. So in development, we know parietal epithelial cells can march around Bowman's capsule by lineage tracing studies from Marcus Moeller and Toby Huber and reach the tuft. And in some injury settings postnatally, like a crescentic rapidly progressive GM, they can do this. In more slowly progressive disease, very nice evidence from Marcus Moeller supports in animal models that the parietal epithelial cells go to the tuft but make sclerotic matrix and are prosclerotic. In our animal studies, it seems that if we can change the phenotype of the parietal epithelial cells, we are interested in PI1, plasminogen activator inhibitor 1, we can make them be reparative, more like podocytes, instead of prosclerotic. So there is potential. The proximal tubular outlet cells may also have a stem cell function. We know that we must have some ability to replace podocytes because all of us are losing podocytes in our urine every day. Not so many, but if we didn't have some minimal replacement mechanism, we would all be on dialysis by age 20, if you calculate, and we're not. So there is some very minimal replacement mechanism. The leading hypotheses now are from the parietal epithelial cells, from Stuart Shanklin's group, from the renin-positive progenitor cells, and from Ariel Gomez's group, and the proximal tubular cells. But we don't have lineage tracing in humans, so we don't know the exact answer. Yes.
Bueno, tenemos